Hello, welcome back students. Today we are going to start with an interesting topic inside an atom. Chapter number 5. If you want to learn the interesting topic of this chapter, please do watch entire video. So student, what we are going to learn in this video, what are the learning objectives? So here is the types of substances, Dalton's atomic theory. Dalton, he was a scientist who discovered what was the things present inside the atom. An atom, what it is made up of. The next was Thomson's plum pudding model of atom. And the last, Rutherford's nuclear model of atom in the year 1911. Now let us see what they did and what were the things which were found inside the atom by this scientist. Let's recall few questions. What is mean by matter? Student, you all are aware that matter is made up of very small particle, very small, very tiny particles. Okay. Now, what is an atom? So, an atom is the smallest particle of an element. Okay, atom is the smallest particle of element. Student, you are very much familiar with the word oxygen. Okay, so oxygen is nothing but one kind of a element. Okay, so like that many elements are present. Many means 108 elements are present on this planet, in which 99 were naturally found on this planet and rest is man-made. Okay, so students, it's a smallest particle of an element which have its chemical identity in all physical and chemical changes, whether it's a chemical change or a physical change, but the atom which is in element is not going to change. It will retain its properties. And the last one, what is the smallest unit of matter? So an atom is the smallest unit of matter. As you can see, this is the image of one of the element called lithium atom. As you can see, inside proton and nucleus, in between there's a nucleus in which there's a proton and neutron is embedded. Okay, it's a constant, it is not a moving. Okay, which one is moving? So electrons keep on moving throughout its orbit. So this is nothing but a atom. Okay, this is a structure of lithium atom. Students, now you understood what is atom. Atom क्या है? Atom is the smallest particle of an element. Element का सबसे छोटा particle, मतलब एक ही kind of atom से बना होता है element. ओके, जैसे कि अभी ऑक्सीजन, हाइड्रोजन, ये सब में क्या होता है? एटम होता है. अब एटम के अंदर क्या होता है वो हम ये चैप्टर में पढ़ेंगे. ओके, बट यू अंडरस्टूड व्हाट इज एटम. एटम से क्या बना हुआ है? सबसे पहले एटम तो सबसे छोटा पार्टिकल होता है और उससे बना होता है एलिमेंट. नाउ इट्स कम्स टू मॉलिक्यूल. अब हमारा नेक्स्ट क्या है? मॉलिक्यूल. अब मॉलिक्यूल क्या होता है स्टूडेंट? जब एक से ज़्यादा एटम मिल के कोई चीज़ बनाते हैं तो उसे बोला जाता है मॉलिक्यूल. जैसे कि तुम यहाँ पे देख रहे हो पिक्चर में, इमेज में, देयर इज़ अ मॉलिक्यूल ऑफ वाटर. ये वाटर है H2O. ओके, 2 H है, एक O है. ओके, इसको बोला जाता है H2O, दैट इज़ अ वाटर. ये क्या है? मॉलिक्यूल है. क्यों मॉलिक्यूल बोला गया है? क्योंकि इसमें एक से ज़्यादा एटम प्रेजेंट है और एलिमेंट प्रेजेंट है, उसे बोला जाता है मॉलिक्यूल. नाउ मॉलिक्यूल इज एन इलेक्ट्रिकली न्यूट्रल, इसे न्यूट्रल बोला गया है, नो चार्ज. ना ही इसके पास पॉजिटिव चार्ज होगा, ना ही इसके पास नेगेटिव चार्ज होगा. Is a electrically neutral group of two or more atoms held together by chemical bonds. ओके, अब आपके राइट हैंड साइड में देखो ऑक्सीजन है O2. ये भी मॉलिक्यूल है बिकॉज यहाँ पे 2 मोल लिए गए हैं ऑक्सीजन के. O बॉन्ड को O बॉन्ड से जोड़ा गया है. ओके, तभी जाके ये O2 बना. तो दिस इज ऑल्सो अ मॉलिक्यूल. नाउ स्टूडेंट यू विल थिंक कि ये O2 क्यों है. ऑक्सीजन को हम यूजुअली O2 ही लिखते हैं. तो ये O2 इसलिए है क्योंकि ये डायटोमिक स्टेज में प्रेजेंट होता है. ओके, सो स्टूडेंट, एनीथिंग दैट हैज मास एंड वॉल्यूम इज अ मैटर. मैटर के पास मास भी होगा और वॉल्यूम भी होगा. Atoms and molecules are a part of matter. Atom is the smallest part of the matter. It cannot be divided further. As you can see on your left hand side, student, matter is divided into a pure substance. Again, pure substance is divided into element and compound. As you can see, element is made up of atom and compound is made up of more than one kind of a element. So student, now on page number 28 you have one table 5.1 shows names and formulae of some substances. Now we have to complete the table by putting tick marks in appropriate box to indicate the information of the smallest particle and the type of matter. Now first, second and third is already done for you. What does this column consist of, student? First, name of substance. Second, formula, whether it's a atom, whether it's a molecule, whether it's a single type of atoms in the molecule, different types of atoms in the molecule, is it element or is it a compound. Okay, now first, as you can see, H2O, it's a water. Is it atom? I told you no atom, so it's a molecule. Why molecule? Because it is made up of more than 2 atom or element. As you can see, H2O. Okay, now there's a single type of atom. No, as you can see, hydrogen, H is also there, and oxygen, O is also there, means 2 type of element is present. This is not a single type of atom. There's a 2 type of atom, means different types of atom in the molecule. So tick will be on different types of atom. Is it a element? No. Is it a compound? Yes, it's a compound. Now O2, I taught you this is a molecule. Then single type of atom? Yes. See, only oxygen is present? Yes. Then is it element? Yes, it's a element present in a diatomic state. Okay, this will you are going to learn in detail in your further standards. Okay, now next is He, that is helium. Okay, is it an atom? Yes, helium is written as an atom. Is a molecule? No. Is a single type? Yes. Is it element? Yes. So now I hope you all understood. You are going to do this entire table into your notebook. So student, the first scientist who came to discover atom was Dalton's atomic theory. Student, he was a great British scientist named John Dalton. He put forth his theory in the year 1803 AD. He celebrated atomic theory. Student, according to John Dalton's theory, he stated that matter is made up of atoms. As you can see, this matter is made up of atoms. And atoms are indivisible. Indivisible means which cannot be separated further. And indestructible means which cannot be destroyed. A small activity based on his theory is that take a bundi ka laddu or a solid ball, press both these spheres with your palms. What did you find? Cut the solid ball with a sharp knife. What did you find? Student, a bundi laddu is found to have an internal structure. As you can see how small particles are there. This is nothing but an internal structure of laddu. It is formed by sticking smaller particle, the bundis, to each other. However, the solid ball, broadly speaking, does not have any internal structure. The atom as described by Dalton turns out to be a hard, solid sphere with no internal structure. So, according to Dalton's atomic theory, the mass is distributed uniformly in an atom. Now student, the next scientist was J.J. Thomson. He demonstrated experimentally that the negatively charged particle inside an atom has a mass of 1800 times less than a hydrogen atom. Then later these particles were named as electrons. Okay, this negatively charged particle which he founded was named as electron. Common substances are usually electrically neutral, which means that no charge. Obviously, the molecule of substances and the atom which combine chemically to form molecules are electrically neutral. But student, there was a problem with the J.J. Thomson's discovery. How is an atom electrically neutral in spite of having negatively charged electron in it? उन्होंने क्या बोला कि उसके अंदर नेगेटिव चार्ज है, बट उन्होंने ये भी बोला कि वो इलेक्ट्रिकली न्यूट्रल है, मतलब नो चार्ज. तो ये कैसे पॉसिबल हुआ? तो इसके लिए J.J. Thomson overcame this difficulty by putting forth the plum-pudding model of atomic structure. फिर उन्होंने एक दूसरा इन्वेंशन किया, मतलब डिस्कवरी किया, उसका नाम था Thomson's plum-pudding model of atom. So student, the plum-pudding model of atom put forth by Thomson in the year 1904 is the first model of atomic structure. So student, according to this model, this plum-pudding model, उन्होंने क्या बोला कि पॉजिटिव चार्ज इज डिस्ट्रीब्यूटेड थ्रू आउट द एटम. पॉजिटिव चार्ज पूरे एटम में डिस्ट्रीब्यूटेड है एंड नेगेटिवली चार्ज इलेक्ट्रॉन्स आर एम्बेडेड इन इट, और जो नेगेटिव चार्ज है वो उसके अंदर एम्बेडेड है. सो द डिस्ट्रीब्यूटेड पॉजिटिव चार्ज is balanced by the negative charge on the electrons. Therefore, the atom becomes electrically neutral. अब वहाँ पे पॉजिटिव चार्ज भी है एटम के अंदर और नेगेटिव चार्ज भी है, तो पॉजिटिव चार्ज ने नेगेटिव चार्ज को बैलेंस कर लिया और बैलेंस करने के वजह से वहाँ पे कोई चार्ज ही नहीं बचा। इसके लिए वो क्या हो गया, इलेक्ट्रिकली न्यूट्रल, मतलब नो चार्ज। Still student, the theory on atom has not been fully discovered. So, by these two scientists. Still student, the theory on atom has not been fully discovered. So, by these two scientists. So, now the third scientist came and his discovery was Rutherford's nuclear model of atom, and this was happened in the year 1911. So, the scientist's name was Rutherford. He studied the inside of atom by his celebrated scattering experiment and put forth the nuclear model of atom in the year 1911. So student, what he did in his discovery, Rutherford took a very thin gold foil. Okay, thickness was about 10 raised to minus 4 mm and bombarded it with positively charged alpha particles emitted by a radioactive element. Student, he observed that the path of alpha particles by means of a fluorescent screen around the gold foil. It was expected that alpha particle would get reflected from the gold foil if the positively charged mass were evenly distributed inside the atom. अब जे थॉमसन सर ने क्या बोला था कि पॉजिटिव चार्ज पूरी तरह से इवनली डिस्ट्रीब्यूट है एटम के अंदर, तो उन्होंने क्या सोचा कि एक फॉइल रखा, गोल्ड फॉइल बीच में, और वहाँ से उन्होंने क्या बम्बार्ड किया, अल्फा पार्टिकल्स। एंड ही थॉट कि अगर पूरी तरह से पॉजिटिव चार्ज है तो जो अल्फा पार्टिकल है वो रिफ्लेक्ट हो जाएगा, मतलब टकरा के, जैसे मिरर होता है वो रिफ्लेक्ट बैक हो जाएगा। बट क्या हो गया, अनएक्सपेक्टेडली मोस्ट ऑफ द अल्फा पार्टिकल्स वेंट स्ट्रेट थ्रू द फॉइल, फॉइल के अंदर से गए कोई अल्फा पार्टिकल्स। अ स्मॉल नंबर ऑफ अल्फा पार्टिकल्स गेट डिफ्लेक्टेड फ्रॉम द ओरिजिनल पाथ थ्रू अ स्मॉल एंगल. A still smaller number of alpha particles get deflected through a large angle, and surprisingly one alpha particle out of 20,000 bounced back in the direction opposite to the original path. So student, the large number of alpha particle that went straight through the foil indicate that there was no obstacle in their path. कोई रुकावट नहीं थी उनके रास्ते में. It means that there must be mainly an empty space. खाली जगह होगी inside the atoms in the solid gold foil. The small number of alpha particles that get deflected through a small or a big angle must have faced an obstacle in their path. मतलब जो डिफ्लेक्ट हो गए वहाँ पे, मतलब रास्ते से थोड़ा टेढ़ा हो गए, दैट मीन्स उनके बीच में कोई ना कोई रुकावट होगी. It means that the positively charged and heavy part causing obstruction would be in the center of the atom. From this, Rutherford put forth a nuclear model for atom as follow. There is a positively charged nucleus at the center of an atom. Almost the entire mass of the atom is concentrated in the nucleus. Negatively charged particles called electrons revolve around the nucleus. The total negative charge on all the electron is equal to the positive charge on the nucleus. As the opposite charges are balanced, the atom is electrically neutral. There is an empty space between the revolving electron and the atomic nucleus. So student, now use your brain power to answer few questions. Which discovery did point out that an atom has internal structure? Think student. So here is the answer, that Thomson's atomic model discovered that an atom has internal structure. Next question, what is the difference between the solid atom in Dalton's atomic theory and Thomson's atomic model? So, Dalton's atomic theory explains atom is a hard sphere, while Thomson's atomic theory explains atom has plum pudding model. Explain the difference between the distribution of positive charge in Thomson's atomic model and Rutherford atomic model. So here is the answer. In Thomson's model, positive charge is distributed, and in Rutherford's model, positive charge is in the nucleus. What is the point difference between the place of electron in the atomic models of Thomson and Rutherford? So, in Thomson model of electrons are embedded in positive charge, while in Rutherford's model electrons revolve around the nucleus. And the last one, what is the thing which is present in Rutherford's atomic model and not present in Dalton's and Thomson's atomic models? So student, here is the answer. Rutherford explained empty spaces between electrons and nucleus, which is not given by Thomson's and Dalton's atomic model. Okay students, now do a small assignment based on this video. What is the difference in the atomic models of Thomson and Rutherford? Define atom. Describe Dalton's atomic theory. Describe Thomson's plum pudding model of atom. Describe Rutherford's nuclear model of atom. Draw a neat label diagram of Rutherford's scattering experiment and Thomson plum pudding model. So student, I hope you all understood whatever has been taught today in this video. So student, in next video we are going to continue next topic of this chapter. So student, if you like my video and you want me to make such an educational video, do like, share and subscribe my YouTube channel. Till then student, take care. Thank you.